Here's an easy way to remember that del dot f computes divergence, while del cross f computes curl. After showing you how you can remember this by some extreme examples, I'll walk through several others to give you an intuition for why this notation even makes sense. Here I've drawn several vector fields f in black, and I'm assuming you're familiar with vector fields as well as the geometric interpretations of the dot and cross product. This first vector field clearly has positive divergence, as you can imagine this point being a source in fluid flow. Now I like to think of del as a little step vector. And to compute del dot f, we'll just take little steps and take their dot product with the vector in the field that we step to. So here's what that means. Let's take a little step, and then we'll take the dot product between this vector and this vector. Now you can see, since they're pointing in the same direction, that's going to be positive for del dot f. But now you can think, if you're to take the cross product between these two vectors, it would be 0 because they're pointing in the same direction. So we have 0 for del cross f. Alright, now del dot f is actually the average of all the dot products if we were to take steps in all the possible directions. So let's take a few other directions to see how that works. So if we go a little step that way, you can see these are also pointing in the same direction, so del dot f is going to be positive. Well, del cross f, of course, is going to be 0. And you can imagine we take a step this way, all the ways we could go. And in all the cases, we have del dot f as being greater than 0, while del cross f equals 0. So in this extreme example of positive divergence, the little step vector dotted with the vector it reaches is always positive, whereas if we take the cross product, it's always 0. So you can remember that in this positive divergence, the dot product between del and f is positive. And so that might help you remember that del dot f gives the divergence. Now, to see the same thing in curl, here's an example, an extreme example of curl. And so we'd expect that del dot f would be 0 since there's no divergence, but del cross f should be positive. So let's do the same procedure. We take a little step, and so here you can see we step to a vector that's perpendicular to the little step. So of course del dot f is going to be 0, but because this makes a little 90-degree angle, but this is maximizing the area between these two vectors. So we can see that del cross f is going to be greater than 0. Same thing if we took a vector off this way, or this way, or this way. In each of these directions, it's quite clear that these make a 90-degree angle, and so you can remember that curl, which is del cross f, that's going to be positive because this has positive curl. But of course, divergence, del dot f, it's just 0 on this case because this is a curl example and it has 0 divergence. Now, if you just wanted a quick trick to remember that del dot f it corresponds with divergence, while del cross f corresponds with curl, well, this is probably enough